All right, let's talk about Chapter 8, SQL Function and Procedures. There's the objectives. You can read them as you're reading the book. Using SQL in a programming environment. SQL is a non-procedural language where it just uses simple commands to communicate tasks to the computer. PLSQL is a procedural language. It must provide step-by-step processing for accomplishing these tasks. Can embed SQL in other languages such as PSQL or TSQL. It's useful when needed tasks are beyond the capabilities of SQL. Cannot embed SQL commands in Access. Using functions, aggregate functions. All the aggregate functions must be based on groups of records, which means you have to have a group by command. Sum is an example. Average would be another example. Other SQL functions affect single records, varies from one SQL implementation to the other. You have the upper function, displays the value in uppercase letters. Function operates on an argument. Lower function puts it in lowercase letters. Can use functions in where clauses. In Access, instead of using upper and lower, it would be U case and L case. Here's an example. They're going to make the argument last name all uppercase. So no matter how it was entered, it's going to show up all uppercase. Round function. It rounds to the number decimal position you provide. It requires two arguments. The field is the first argument, and then the second argument is the decimal positions. The floor truncates everything to the right of the decimal. It's not supported by Access. What that means is, if it's a hourly rate and you make $15.99, if you do the floor, you're only going to make $15. And here's the example of the round. So I want you to take the price field, make it 0 decimals. So anything from 0.5 or above, it's going to round up. So if it was 23.49, it would be 23. If it was 23.50, it would show up 24. Working with dates, you have an add underscore months, add specific months, number of months to the date. You got to put the field name and then the number of months you want to add. Access and SQL Server use date add functions to add months. Add a specific number of days, use a simple calculation and can also subtract. MySQL doesn't use date add. It wouldn't work, or it doesn't work, I should say. But here's what I do on this chapter. Some students will test it through SQL, which is what I'd like for you to do. But in doing that, you have to go to Google and figure out, type in, like to add months, you'd have to type in MySQL, add months, and it would give you a list of them. All right. And some students, they just put down what's in the book, because they don't want to test it in MySQL. I'm leaving that up to you. I'd rather you look at Google and figure it out, but I don't count off if you just use what's in the book. CIST date obtains today's date in Oracle. Date procedure, access, get date in MySQL. And again, Google in MySQL, I see SQL Server. I think I said MySQL down here, but I meant SQL Server. Do MySQL, get the date, Google it, and it will show you. It's pretty simple. Here's an example of the add months. It says, hey, I want you to add 2 months to the order date. So you order something and they give you 60 days to pay, which is basically 2 months. Some months it may be 62 days, but that's how you do it. To add days, order date plus 7. And I can tell you that neither one of them will work in MySQL. Okay, so you have to Google it if you don't want to do it this way. Subtract date, minus orders date, 2 days. I said 2 days, 2 decimals. So from today's date, which is CIST date, to the date was ordered, It was 29.53 days ago. Concatenating columns. It's where you combine two columns together. In Oracle, use two vertical lines, the ampersand and the plus sign, and you can read the accesses SQL. Our trim function removes extra spaces to the right of a value. You say, well, why would they have extra spaces? You know, like if you enter in a first name and your first name's Jack, all it's going to have is Jack in there. But if the user, when they entered in, puts in Jack and hits the space bar 5 times, it would have Jack and 5 spaces. So even though that's a rare occurrence, most developers, they do the R trim on every field that they're, may have when they're concatenating and everything, because you never know how the user entered it. R trim first name, concatenate that with the space, R trim last name. Even though they're not concatenated everything anyway with anything, the industry standard is you do R trims every time you concatenate. So Raphael campus. In my previous example, if they typed in Raphael and did 5 spaces, you'd have, if you didn't do the R trim, you'd see the 5 spaces here. But the R trim gets rid of all those, and that's why you only see one no matter what. Stored procedures. They're useful in client-server systems. The advantage is stored on the server. The database management system compiles the procedure, creates compiled, and then optimizes the code to run. It just reduces typing is another convenience. Access is not supports it. All right, you do that, you use the create procedure command. The %type attributes ensure that the variable has the same data type as a particular column. This saves you a little time because you don't have to go back and see what the data type is of every column or every field that you have in your database. You can just always use %type, and no matter what it is, it'll make it that data type. Procedural code is located between begin and end commands. Each variable declaration and commands, as well as the word end, are followed by semicolons. You use the / at the end of the program, appears on its own line. All right, so here's the procedure name. This is the arguments. That is going to, when you call it, you got to pass. So it's going to take the rep number that you pass, store it in the IREP number. All right, then it's going to go down here, and this is just declaring your variables. Then it's going to go down here. Here's the begin it was talking about. It's going to select the last name and first name, move it into the local variables up here from the rep table where the rep num equals the IREP num, which is what was passed to it when you called. And it's going to go through there to get that information and output it, concatenate it. All right, so that's pretty much everything I just told you. The DBMS underscore output is a package that contains multiple procedures. To call a procedure, you type begin, the name of the procedure, argument in parentheses, and the end, and semicolon /. Begin, the name of the procedure, the argument you're going to pass, and the end. And of course, the /. And it returns Megan Grady, which tells you that rep number 30 is Megan Grady. Error handling. Remember I told you previous chapter you got to have error handling. In procedures, you do the exception keyword. It says when no data is found, then output no rep for this number, because you may have passed the rep number that the rep has got fired or quit, no longer there, or you passed the wrong one. It will give you that error. If you didn't do that, it just crash your program. Some cases. Using update procedures. Of course, it does what it says, it updates it. So here's how this works. There's a name again. There's what you're passing. Here's a local variable. You do the update customer, same SQL command you've been using, right? Update customer, set customer name equals iCustomer name. So this iCustomer name is what was passed. Where customer num equals the pass. I said that backwards. The customer num is what was passed. All right. So where it has the correct customer num, it's going to move the name to the customer name. So when you call it 2260 Brookings Family Store, that's what happens. So whatever 260 used to then be Brookings Family Store. You know that because they're using the update command. Used to be something else. Deleting data works the same way as the updating, except you use the delete command. Notice what they're doing though. They have the order table, but since the order line table is tied to it, they got to delete both of them because this is the parent table, that's the child table. So for every order you have, if you ordered one item, you're going to have one order line. If you ordered 10 items, you'd have 10 order lines. So you got to delete the order lines first before you delete the orders. If I delete order number 1 and it has 10 order lines and I delete them, I'm going to have 10 what they call orphan records out there that you have no idea who ordered them because you don't have the order record in the order table. Selecting multiple rows within a procedure. Use PL/SQL can process one record at a time. You use a cursor as a point of a row to get multiple records or to tell you where you're at. It just goes one at a time through your table. So first step is you declare the cursor. Okay, that's what you're doing here. Select customer num, customer name from customer where rep number equals IREP number. Then you have 3 commands. You got open, fetch, and close. So the open command, of course, opens the cursor, causes the query to be executed, makes results available to the program. Prior to the opening, there's no records available to be fetched. So to open it, you say open cus group. Again, that's what you named it back here. And it goes through, this is before the open. Okay. In memory, when you create it and everything, you got customer and called it, you got customer 126 in there. All right. After the open, before the fetch, it goes down to the next one. That's just the way it works. A little confusing, because, I would, just thinking about it, I would think, well, you know what? You open it up, then you have to fetch the first record, and then so on. But that's not the way it works. It already has the first record in there. And I already told you this: the fetch command advances the cursor to the next row in this retrieve row to place the contents of the row in the indicated variables, which the execution of the fetch command produces only a single row. So it just walks you through that. When you can read over it. When you get on down to it, it's no more rows are fetched. Then it's going to come out and it's going to let you know you need to close it. That's what this is doing here. This is what the when customer group % not found, which means when you hit the end of the file and there's no record to fetch, that's when it exits out. They're passing customer number 15. Okay. And then they're fetching. So there's 15 customers that has the 15. There's 4 customers that has the rep number 15. You can use more complex cursors. Here's a typo. SQL query is legitimate in a cursor different. I'm sorry. Any SQL query is legitimate in a cursor definition. More complicated retrieval requirements result in greater benefits. And you can see this. This works similar to what we've been doing, except it's just adding multiple tables. All right, so you have the name of it. This is what you're passing. Then, you're getting this many variables. That's how much you're getting from the different tables. And these are the qualified names, Then you select those. You do an order line, orders, custom and rep table. Same commands you've been doing previous chapters. You tie those tables together and everything. But then when you go down here to the fetch, it's very similar, right? You just fetch it the same way. You do the exit the same way, but you output. You're not doing concatenation. You're outputting all on a separate line. Advantages of cursors. simplifies the coding. Programs with embedded SQL utilizes the optimizer. I don't know if you know what the optimizer is, but every time you run an SQL statement, the database management system determines which it does what they call optimizing, and it determines which is the best way to execute that to make it run faster. Yeah, what's the big deal? The big deal, it may be running against millions and millions of records. So you want it to run as fast as possible. The programmer doesn't have to worry about the best way to retrieve it. The program doesn't have to change even if the underlying structure changes. The cursor definition only changes, not the procedural code. They have a thing called TSQL in SQL Server. It's the extended version of SQL. I think it stands for transact. You create stored procedures and use cursors. Here's the difference to what we did earlier. You have to assign a data type. Remember last time we used that parameter that automatically did the data type? And in arguments, you have to start them with the @ symbol. So here's the example. You got the same name, but there's the argument. There's the data type. The rest of them work pretty much the same. This is one changing it. There's a data types, the @ symbol. You call it a little bit different, but they all work the same. And you can see that that's delete works the same. Just remember, you got to put the data type in on the arguments. And you got to use the @ symbols on the arguments. That's it. And anytime you use the order number, like even down here, you got to use it. Using a cursor, well, it works the same way, except you just use the @ stuff. It says while fetch status equals 0 instead of, now it's a little bit different. Using more complex cursors, you declare all variables, declare cursor, select statement, open cursor fetch, while loop, close, and deallocate. In Access, programs are written in Visual Basic. We're going to skip all through this Visual Basic. Most companies never going to use Access as their database management system. Too much proprietary stuff in there. Finding multiple rows with Visual Basic, we don't care about Visual Basic. Trigger. A trigger is anytime a function or some action happens inside your database, that trigger causes something else to happen. You do that by saying create trigger. SQL commands between the begin and end, new qualifier, and then the old qualifier. So you create a trigger, and what this is saying, after an insert on the order line table, for each row, I want you to update the item. So this is just adding whatever the quantity is ordered to the on order. The replay update is subtracting the new number from the old number. For example, if you had 10 in stock, you order 5, it would change it, or 6, it would change it to 4. Excuse me. And delete, it's just deleting whatever the none that was ordered from the on order. TSQL using a trigger. I'm going to zoom through this because I think my WebEx is fixing to kick off. You can look over that and have any questions, call. I hope this helped. Thank you.